Hey everybody, this is Reed David Hoffman here to present Advanced Concepts presentation number 5 for Biochem 330. And today we're going to be talking about cellular respiration. And so first of all, the question is, what is cellular respiration? And the answer is that it's a biochemical pathway by which cells release energy from the chemical bonds of food molecules and provide the energy that's essential for the processes of life. It allows the body to harvest a large amount of energy from one glucose molecule. And 30 ATP can be produced for every one glucose molecule. So my goal today is to show you how we're going to get 30 ATP molecules from one glucose. All right, so first I want to write down the 3 steps that we're going to be talking about. So let's just do let me move this. Sorry. This is going to be the glucose to pyruvate. And that's glycolysis. So the substrate level phosphorylation, we're going to get 2 ATPs from that. And we're also going to get 2 NADH. And so the ATP yield all right, so 2 ATPs, 2 NADH. Now, each NADH can give us 1.5 ATP, so 2 times 1.5 equals 3. So we're getting 3 plus 2, that equals 5 here, and glucose to pyruvate. All right, so here's a chart of glucose to pyruvate. You can see here glucose to pyruvate, and this is the whole cycle going down. And I just wanted to show you that in order to get ATP, we first have to spend ATP. So in the preparatory phase, we're going to be actually using ATP to power this mechanism here. So we're down to, however, we are producing 2 NADHs and we'll end up producing 4 ATPs. You can see that over here in step 6, we're getting NADH, that's the glyceraldehyde 3-phosphate dehydrogenase. And then here in the payoff phase, we're actually starting to produce ATP. So you can see from here, we're producing ATP, and then we're going to end up yielding 5 from the glucose to pyruvate. All right, so I'm just going to quickly write the overall equation for that. Glucose plus 2 ADP plus 2 pi. It's going to give us pyruvate plus 2 ATP plus 2 NADH plus 2H plus. Okay, for the second step, this is going to be pyruvate to acetyl CoA. And the substrate level of phosphorylation on this one, I'm just going to write here, is going to be 0. And then for the NADH, FADH, we're going to get 2 here. Okay, so the ATP yield in this situation is going to be 2 times 2.5, so we're going to end up getting 5 out of the stage B. And let me just show you that reaction. So, okay, so B, we have pyruvate to acetyl CoA, and you can see producing the NADH. There's no ATP produced directly in the cycle, but the NADH is converted to ATP later on. All right. And then third, this is going to be the citric acid cycle. All right, so we start with acetyl CoA, and we're going to end up going through the whole cycle here. Okay, so let's just say for substrate level, it's going to be 2 ATP. We're going to have 6 NADH and 2 FADH. Okay, so the yield 6 times 2.5, that gives us 15. And then 2 FADH is going to be 1.5, so that gives us 3. So that's 18. Plus the 2 ATP, we'll have 20 total. All right, so let me show you the citric acid cycle. Okay, so here's a picture of the citric acid cycle. I actually just went ahead and highlighted the steps of it that are producing NADH, FADH, and ATP. So for each of these boxes you see, that's going to be 2 produced. So you can see in step 4, producing 2 NADH, step 5, 2 NADH, and step 9, the malate, the oxaloacetate, and then the ATP is coming from step 6, which is the succinyl CoA synthetase, and that's going to give us what I was talking about earlier. What I mentioned, we're producing 2 ATP, 6 NADH, 2 FADH, for a total of 20. I just wanted to show you where those are coming from exactly. Okay, so going back here, just to review, we're getting 5 ATPs from glucose to pyruvate. We're getting 5 more from pyruvate to acetyl CoA, and they're getting 20 from the citric acid cycle, and that's going to give us a grand total of 30 ATPs from a single glucose molecule. And I hope this video was informative, and thanks for watching. I really appreciate it. I'll see you back here next week.